Hi, and welcome to the session. Now, before we get started, I just want to do a quick poll to see how many of you use software as a service or SaaS solutions? I think that's most of us. And how many of you have wondered about the security posture of your data and who has access to it in these SaaS solutions? Okay, so that's a lot of us out here. Perfect. I think then you're in the right place. So today we're going to be talking about improving data control using AWS KMS, and also talking about a solution that we built with Zoom. So hi, my name is Amit Kumar Agarwal, and I'm a lead solutions architect here at AWS, and I work very closely with Zoom. With me, I have my colleague Hassan, and from Zoom we also have Karthik Raman, and he's part of the product team who led the solution build out. Now we curated this talk in two different sections. Like, one aspect is for the solution providers, and the other aspect is for customers. So by solution providers, we mean organizations like Zoom who are building on AWS and who want to provide advanced data protection capabilities to their customers. And by customers, we mean joint customers of AWS and also of solution providers like Zoom who desire more control of the data. Now, in this room, how many of you guys identify yourselves as solution providers? Okay, so I see a few of y'all. So I'm assuming the rest of y'all will identify yourselves as customers. So hopefully the session is good for you to identify what direction and what are the steps that you want to take in this journey to improve data control. Now let's get started. From an agenda standpoint, I will talk about the problem statement. We'll also go through some of the high-level concepts and also a solution. And then Karthik is going to come in, and he's going to be talking about Zoom's implementation. And then Hassan here is going to wrap us up with some of the best practices and advanced topics. Now let's look at some of the motivations. Whether you're a customer or whether you're a solution provider, I think the main motivation is that you want stricter control over data access. You want to make absolutely sure on who is accessing the data. And with that, you also want finer grain access control, because it's not just who is accessing the data, but you also want to limit for what purpose they're accessing and also in what circumstances they're accessing the data. And then there comes the other point in terms of visibility and transparency in the way data is handled. The other aspect is also around security, regulatory, and compliance requirements. All of these requirements essentially are leading customers and solution providers for stricter control on the data. Now, when it comes to control and access, we see two distinct scenarios. In one scenario, customers have full access over the data and the applications that have access to it, because they're running this in their own environments or in their own AWS clouds. But in an increasingly second scenario, we see that customers don't have full control of the data and who's accessing it, because the data is in the solution provider's account. In this talk, we will be talking about this specific second scenario. Now, when you think about data protection, I can simply represent it as customers want access to their own data, but via an application that is running in the solution provider's account. Now, the solution provider can take many steps. They can have roles, they can have the right level of permissions, so that they can really fine-grain control the access to the data for specific different customers. Beyond this, the solution providers can also encrypt the data with the right encryption keys. And the solution providers can choose to have multiple different encryption keys for all the different customers that they have. Even if they do this, the customer still does not have fine-grained control over who is accessing the data and in what circumstances. A better approach here would be to grant customers direct control of this particular encryption key. So even though you can have the right permissions and roles to access the data. If you don't have access to the right encryption key, the data is essentially worthless. Now let's look at the encryption keys. Customers have choices with a variety of different ways for encryption keys. They can use symmetric keys, they can use asymmetric keys. And customers have to balance the compliance requirements in the way that they manage keys. So they can have strict control for regulatory requirements, and they would also have to balance the convenience so they can effectively handle and manage the keys. And then the other aspect of key generation. Key generation should be random. And the key lifecycle management should guarantee that the keys are created, accessed, and retired in a secure way. With AWS KMS, all of these requirements are essentially met. And AWS KMS is a powerful service that helps you manage the entire lifecycle management and access control to the keys. It is used by 100+ AWS services, and your applications can use KMS too. One of the benefits of KMS is it is backed by hardware security modules, or HSMs. Recently, the HSMs have been granted FIPS 140-2 Level 3 security certification. And what this means is that your keys never leave the HSMs, and all your cryptographic operations are done within the HSMs. This certification, Level 3 security certification, also allows you for compliance requirements like HIPAA, GDPR, etc. And then everything that is done in KMS is essentially logged and tracked by AWS CloudTrail. Now, from a key store option, there are multiple different key stores that you can use with AWS KMS. On one side, you can use AWS KMS natively, and it provides you with the highest availability and durability that's offered by AWS. It is one of the very few services that offers a remarkable 5 nines of SLA. But if you want more control of your keys, you can also import your keys into KMS. There's also an option of using AWS Cloud HSMs and integrate that with your KMS. But this option will be at least slightly lower transactions per second. On the other extreme, you can also use XKS, or external key store. In this scenario, you're removing the full key material and the root of trust from AWS KMS. This scenario will also lead you to have greater key control and ownership, but is also going to be at a higher cost. Like I was saying before, you have to strike a balance between control, availability, convenience, and cost. And your compliance requirements are going to determine which direction you end up going. Now for AWS KMS, the KMS key itself is not used for encrypting your data in most cases. So AWS KMS can only encrypt data up to 4 kilobytes payload. But if your data is more than 4 kilobytes of payload, which is the most common scenario, we use what we call as data keys. And think about the data key as a random cryptographic key that is used to encrypt and decrypt data. And when your application and services want to encrypt data, they essentially generate a data key, or they can also call KMS to generate a data key for you. And you end up using multiple different data keys, even though you have a single KMS key. And whenever the service wants to decrypt or encrypt your data, they will essentially use their own data key and will do all the operations on it. Now, one of the benefits of using different data keys is that one is it will reduce the blast radius for some reason if the data key is exposed. Only a small set of data is essentially exposed then. Data keys also helps you to improve performance because you can cache these data keys if you are encrypting large amounts of data. And obviously, KMS key cannot be used directly for large amounts of data, so it definitely improves performance from that regard. It also prevents crypto wear out. Now, crypto wear out is a concept when you have too much data which is encrypted by one single key. So in theory, an attacker can observe the ciphertext and can retrieve the key. But if you're using multiple different data keys, it reduces the crypto wear out. The other aspect is that it lowers costs. Now, every API call that you make to the KMS, there's a cost associated with it. But if you are using just data keys, then you don't have to make those API calls, and therefore lowers the costs. Now, before we continue, I want to talk a little bit about envelope encryption, because this is going to be a key concept as we move forward in this talk. Now, essentially, what is envelope encryption? Now, if your data is encrypted by a data key and the data key itself is encrypted by another key, that is called envelope encryption. Now, in this case, what happens? Let's see. So one side you have a data key and you have data, and the data key is used to encrypt the data, so you get encrypted data. But then what happens to the data key? The data key itself is encrypted by the KMS key. And what you get is the encrypted data key. Now, both the encrypted data key and the encrypted data are stored together. Now, you might ask, hey, what's going to happen with the KMS key itself? Well, the KMS key is encrypted further by what we call as a domain key. And this essentially becomes your root of trust within KMS. And your key never leaves the service. Now, if an application wants to access this data, they essentially will take the encrypted data key and will send it to the KMS service. The KMS service will decrypt the data key and will give you the plaintext data key back. And the application is now going to use this plaintext data key to retrieve the data. Now, this is the fundamental concept of envelope encryption, and it is used in the solution that we're going to be talking about. Now, these KMS keys can be in the same account, and this is a typical scenario that we see, where you have your application and your data also residing in the same account. But in the solution that we are interested in, the data is not in the customer account, but the KMS key can be part of the customer account, while the data and the application still can be part of the solution provider's account. And the solution provider can call the AWS KMS in the customer account for all encrypt and decrypt operations. They do what is called as a cross-account AWS KMS call. And the customer has full control over the data. The customer has full control over the KMS key. And they can have the right levels of roles and key policies, and they can identify who can access it and when and for what purpose. In this sort of an architecture, there's a shared responsibility model. From the solution provider side, they essentially have to do two things. One is they need to encrypt the assets that they claim needs to be encrypted. And if you saw the way I explained envelope encryption, they also have to discard the plaintext data key once encryption is done. So that's the responsibility on their side. From the customer standpoint, they are responsible for the entire key lifecycle, how it's created, how it's managed, and how it's how you grant access to it, with the right level of roles and policies to the solution provider. With that, I will call Karthik to talk about Zoom's implementation. Thanks.
Thank you very much, Amit. It's a pleasure to be here. Thank you for having us here. I'm excited to tell you a little bit about what Zoom has done to implement these technologies, and from a solution provider's perspective, working with AWS, bring an enhanced experience of encryption to the customer data that are stored inside Zoom. Who is Zoom? We've all heard of it. We shot to prominence during the pandemic. We've got, in addition to meetings, several other workloads, including meetings, webinar, team chat, phone, contact center, and we're a platform that is aimed to go beyond video communications. What I'm excited to tell you about over the next few slides is our story of how we work with AWS to bring that enhanced encryption to the data that are stored in many of these workloads. 2 years ago, we started to get very interesting feature requests from customers. Lots of big customers in finance, and many of these customers based in Europe came to Zoom and said, look, Zoom, I'm looking for a way to protect the data that are stored inside your trust boundary, inside your cloud. And I need to do that for several reasons. And so the common thread through a lot of these customer conversations was a pattern that's known in the industry as bring your own key. So let's double click into some of the motivations, and I'd like to ask you to think about, as a customer sitting in the audience, does one of these motivations resonate with you? So the most common one I just covered. As a customer, you're looking for a way to have enhanced protection over the data that you're storing inside the Zoom trust boundary. And you want to have this ability to protect that data at rest as it's sitting there inside the Zoom trust boundary. Another camp of customers were driven by their compliance teams. Compliance teams had very clear checklists that would spell out the need to work with vendors and seek out vendors that would provide bring your own key solutions to them. Right? So you're working with your compliance teams and they say, look, you have to requisition vendors that bring your own key technology so we get that compliance checklist to go with it. A third camp of customers came to us and said, look, we understand the story of data storage. We are a European company and we want the ability to get to data residency in a manner in which we can store our keys in Europe, but have those keys encrypt and protect data stored anywhere else in the world. And a fourth category of customers were advanced security customers. So think of the enterprise software companies of the world who are producing security software. And they are looking for every way to minimize the risk to their operations from a supply chain perspective. And so if you think of vendors that they work with, solution providers that they work with, companies such as that are looking for every way to mitigate risk and minimize risk through their supply chain. So when we integrated these perspectives from various customers, the through line was what's known in the industry as bring your own key. And so to cut to the chase, we've got in market today a product, Zoom's got in market today a product called Customer Managed Key. And we are basically able to meet the customer requirements that we heard from customers coming from those four camps. And this technology works with AWS KMS. It works with a variety of different workloads to protect those different types of data assets. And I'll double click into a lot of this. And it also helps you, the customer, provision, set up, and manage keys through our Zoom web portal. So in a single slide, this is the solution we built in response to customer requirements from those four camps of customers. Let's look behind the curtain a little bit further. As of today, we support these various different types of data assets to become encrypted using keys that you control in AWS KMS. The obvious one is meeting webinars. You've got a meeting assets that's encrypted with a key that you control. You've got phone voicemail recording, access tokens for Zoom Room, archiving content, team chat messages. And we also have a roadmap that builds on top of this, but this is what we cover as of today with protection for the workloads inside the Zoom platform. Let's peel the onion further and take you behind the curtains and show you what is the architecture, what is the workflow, how does this data actually get protected with the key that you set up in AWS KMS. So I'm going to go left to right in this picture and kind of walk you through what's happening behind the scenes. So starting in the box on the left-hand side, this is actually where a piece of content, let's say a meeting recording, is stored on disk. So this could be S3 storage. But before that, what is the service that's actually requesting a key to encrypt that content? That's a Zoom service such as meeting or webinar or team chat and what have you. What Zoom has done is build a service to abstract away the complexity of actually communicating with the customer KMS. We've built a new service called the Zoom Key Broker. So internal Zoom services actually make these requests to say, hey, give me a key to encrypt this new piece of content. Or here's an old piece of content that I'd like to decrypt. And all those requests are, in fact, directed not to the customer KMS directly, but into the Zoom Key Broker service. So the complexity of making customer API calls to the KMS is abstracted away from individual Zoom services. The next thing the Zoom Key Broker service does is make that API call to the customer account that we've set up with our customers. So we get a key back, and then the messages go back to the service that requested it, and we encrypt the data and write it to disk. So in a single slide, this is kind of the abstraction of how Zoom actually encrypts that data and writes that data to disk. Now you're probably wondering, I'd like to understand the decryption workflow further, so let me walk you through the step-by-step process of how all this happens. So let's say there was a meeting that you wish to record, you click the record button, and you're actually a bona fide customer of Zoom. What happens behind the scene is that service is now going to request the Zoom Key Broker. The blue icon represents content that's not yet encrypted. That service requests the Zoom Key Broker, hey, give me a data key to encrypt this data. We, as I mentioned in the previous slide, we make that API call to the customer KMS. And what happens in step number 3 is an important point, right? One of the huge benefits of a system with bring your own key is that the customer not only gets enhanced security by virtue of the key that they control and use to encrypt customer content, but also there's visibility and transparency. And so any API calls into the AWS KMS service are automatically logged in CloudTrail. And that gives the customer visibility into what's happening. How is this service provider behaving with me? And am I actually getting that transparency about encryption and decryption? And the answer is yes, you are. Once that's done, the KMS, in this example, we're generating a new data key to encrypt data. So the KMS responds with 2 keys. The blue and the green indicate to you that one of those keys is encrypted. The other is plain text, but they're identical. It's basically a plain text data key and its encrypted equivalent. And those are passed back to the Zoom Key Broker, which in turn passes that plain text data key to the service that requested it. Now, if I'm the meeting service, to wind it back, I get a data key back, and the complexity of where that key came from is abstracted away from me, and that's well and good for me. So now I take that key and encrypt the meeting recording, and I write it to disk. Now, in passing, Amit had mentioned on one of his slides that Zoom does need to store a copy of the encrypted data key. And that's because that's going to facilitate decryption. Let's understand that further. So let's say some time passes, you recorded a Zoom meeting, you can verify in your CloudTrail that that content was encrypted. But some time passes and one of your users wants to view that meeting recording. What happens next? The Zoom service, once again, the meeting service, is able to make an API call to the Zoom Key Broker, but instead of saying, hey, give me a new data key for encryption, this time it's about, hey, here's an encrypted data key, please get this decrypted for me. And that request is once again forwarded to the customer KMS. It's once again logged so that you've got a trail of encryptions, but as well decryptions. And instead of generating new data keys, this time the KMS is able to respond to you by saying, here's the plain text version of that thing that you sent to me, which happens to be this data key. Zoom Key Broker retrieves that, passes that plain text data key once again to the service that requested it, and lo and behold, transparently to the end user, if this workflow is working as it's designed to work, transparently to the end user, they're able to view the meeting recording. That's one of the points I want to emphasize is that the system, if it's designed and implemented well, is going to be transparent to our end users. Now, there may be errors in certain processing based on the configurations done by the system administrator, but the whole design of the system is to keep user experience in mind so that there's no friction in how these encryption decryption operations are carried out. What is the perspective of a customer administrator if they've signed up for Zoom Customer Managed Key? This is, as the slide says, it's a hold your own key model, which, as Amit was referring to, the AWS KMS key never leaves your AWS service. It never leaves the customer trust boundary, and Zoom never has access to that parent key. Instead, as I've described in the last 3 slides, we always make requests to say, give me a data key for encryption or give me a data key for decryption. Now, we highly encourage customers to set up multi-region keys. And this is going to kind of help you in case of issues, or you want to make sure there's redundancy and availability for the key, because we can only support encryption and decryption to the extent that your keys are available to us to make those API calls. So the customer administrator, to go back to that topic, we assume they've set up multi-region keys correctly. And then when they jump into the Zoom web portal, you've purchased the product, you'll see a portion of the web portal in which you're able to enter the ARN, the Amazon resource name, for the key that you set up. Now, once again, we're grateful for the partnership with AWS, because in the initial designs, we actually had customers enter multiple different key IDs, right? And then AWS introduced the multi-region key service, which made life simple, not only for you, the customer, because the same key material was transparently replicated to multiple regions, but also for us, the service provider, because all you had to do was give us a single key ID to manage that complexity. So once the key ID is entered, the customer will have the opportunity to go in and specify the workloads or data assets that will get encrypted with data keys generated from the source you supplied. And as we mentioned here, we don't store plain text data keys in long-term storage. After about a 5-minute period, if there's a request to decrypt an asset, we will make that API call into the customer. Customer Managed Key is a paid service, and so customers can get it through a couple of different ways. There's a bundle called Zoom One Plus Enterprise, through which it's available. There's also an add-on SKU. But there's the ability for customers to purchase a certain number of licenses and provision those individuals against Customer Managed Key to use encryption in that way. You're able to view which keys you've provisioned with us, and we want to make sure that we're as transparent as possible. And so if there's a key at any point that is unavailable, we will make that known to you via multiple different ways. There's a way to specify, send me an email when the key becomes unavailable. We also recently released a feature that lets administrators find out through the alerting and notification mechanism of Zoom that there's something amiss with key availability. So just to summarize, right, this whole premise of Customer Managed Key and Bring Your Own Key as a pattern is that the service provider does not have access to the parent key. That key is always sitting inside your AWS KMS. We will make API calls to you to request data keys to encrypt and decrypt data. And thanks to the tight coupling between AWS KMS and CloudTrail, you will always have visibility over those API calls. We're constantly talking to customers to figure out other additional workloads and assets to protect. There's examples coming from Zoom Contact Center, Zoom IQ. And so if you're interested in the service, please get a hold of us after the talk. But before we do that, I want to hand it back to Hassan, who's going to talk about best practices and technical details.
Thank you, Karthik. My fellow speakers have taken you on a journey through the fundamentals of Key Management Service and also showcased a solution that Zoom developed to protect customer data. My name is Hassan Tariq. I'm a Principal Solutions Architect with AWS. For the remainder of the session, my objective is to give you some actionable advice that you can use while building this solution. Cost saving is top of mind for everyone. So the first topic I like to cover is something that can help providers save cost, and that is the data key caching. So we reviewed this architecture when Amit presented, and also on a similar lines when Karthik was presenting the Zoom implementation, where the key broker service sitting in the provider's account makes cross-account API calls to KMS in customer's account. Now, as the usage of the customer grows, the number of API calls will also grow proportionally. And on the other hand, when the providers onboards new customers, the overall volume of these calls can grow exponentially and can become very high. So why is this a problem? In the configuration that we see here, where the calls are always cross-account, transmitting from one particular account to multiple customers' account, it's always going to be the caller, in this case the provider, who pays for these calls. So high volume of call means higher cost. So what can we do to reduce the load or reduce the number of these calls? One strategy or one option is to introduce caching. So this is where you cache the data keys, especially when they're being used in a very short succession. I'll talk about some security considerations later, but in general, caching data keys means you reduce the calls that are going to be cross-account calls from the provider account to the customer account, and this can help you save some cost. In addition to the cost saving, that's not the only advantage the key caching can actually give you. Every AWS service has service quotas, rate limits that are applicable that you have to adhere to. So having a very large volume of these calls mean you can get very close or maybe exceeding that limit. So we want to make sure that you control that limit and have more knobs so which you can turn to make these calls less volume and not hit the service quotas. KMS, depending on the region, there is different limits, like in some regions, the request per second limit starts from 5,500, goes up to 10,000 in some regions, and in some select regions, it's as high as 50K. And this is a soft limit, which means it can be increased. But what you want to make sure is you leave enough headroom for growth whenever you implement a similar solution, because just onboarding a very large customer who has significantly large usage can just exponentially make your call volumes go really, really high. The last advantage that I want to mention is also related to performance. Now, these API calls, even though they are very low single-digit millisecond latency, but when working on a high performance scenario, every millisecond counts. So by avoiding these round trips and using cached data keys, you can gain some performance here. So you have to make sure when you implement data key caching, you need to consider the security implications and the security risks that come with the key caching, especially when you're saving some resource, cost, and money. You have to make sure that you always favor your security requirements. In order to mitigate these risks, it's always best to set some security thresholds. For example, set a time to live, which can be perhaps 5 minutes or less. So the idea of this 5-minute I've taken from some high usage AWS services that cache data keys. For example, the window in which an S3 bucket intermediate key lives before it gets rotated is 5 minutes. You can also add other thresholds like maximum data size, or perhaps the maximum number of events or messages that you serve with that cached key, or all of them, whichever comes first. So if you're using AWS Encryption SDK, data key caching is an optional feature which is built into it, and you can set these security thresholds very easily. When implementing this data key caching, you have to also consider to give transparency and visibility to your customer, because in the end, this customers like to have more visibility into how their data is being accessed. And key caching means it's not making the round trips that we saw, and in the Zoom's presentation, you also saw the round trips getting made to the CloudTrail will not be apparent here. And I'll cover that a little more in detail. So this is a great segue into the next topic. We did talk about some of the motivations that Amit showed in the start, that some of the prime motivation is for customers to have visibility into how their data is accessed, but also have more fine-grained access to how these different data assets are being used. The good news is that the KMS sitting in customer's account integrates really well with CloudTrail. So every API call that is made to customer's KMS gets logged into their CloudTrail event log. And as you can see, as in this example, a decrypt call was made that is logged with some additional information. So once you have all of these API calls getting logged in CloudTrail, you have a lot of options. You can use a tool of, the customer can use a tool of their choice to analyze it further, to debug, to audit these events. Or in AWS, there are many, many options. I can't list all of them, but as an example, from CloudTrail, you can send these logs to CloudWatch and then add alerts or use service like CloudWatch Insights to analyze it further. Or you can choose to send this trail to S3 from where there are multiple options. You can either use Amazon Athena that allows you to write SQL queries to analyze this data further. So now having said that, we have multiple mechanisms, multiple ways to really audit these events and analyze this data. But the quality of the output of that whole analysis is going to be as good as the inputs that you're getting. So if you look at this example event, there was some data that was accessed. It's not giving you a lot of information to work with. It's just giving you some basic, very core information on the time and the type of event. It would be nice if the customer can get more granular information. For example, what kind of service within the provider's account was accessing it? Or perhaps, if this is a Zoom scenario, what was the actual data asset that was being decrypted? Was it a chat transcript? Was it a meeting recording? Or maybe like a whiteboard? So what was actually that details? So what's important is that as a provider, you should add more information to the customer to analyze, and that can easily be done by using a KMS feature called encryptionContext. So encryptionContext is non-secret, plain text additional information that you can add when making any of the API calls like decrypt. So this is consists of a multiple key value pair, making sure there is no sensitive information here because it is going to get logged into CloudTrail. It appears as you can see in this example that this particular decrypt call was made by a service, which may be the meeting recording service, for a particular meeting recording that was retrieved. So this is some information that Zoom is sending. As a provider, you can choose whatever fits best for your customers and your service. And now we can see the customers have a lot more data to really do their audits and analyze it on. So this is great. So far, we have a really good overall process. We gave the customer access to their data, visibility, fine-grained. But if you go back, what about those data elements that were used from the cached keys, that were decrypted using the cached keys? Those will not actually hit customers' CloudTrail. So if there are customers who want that further deeper level of visibility, there are different options also. One of the options is you can ask the customer to create a CloudWatch log group and then create an IAM role that allows the provider permission to write to this log group. So that way, whenever the provider's account or the key service accesses a data key from the cache, you can write a log entry into the customer's CloudWatch. It can be an async log entry call. So blending these two things will give an overall 360-degree view to the customer in how their data is being accessed and give them very fine-grained information. So the next topic I want to bring up is important for providers who are striving to keep their service highly available. And If you have an HA, high availability, or a DR story that spans across multiple AWS regions, multi-region keys can really be helpful for the providers as well as the customers. So this is a topic that Karthik touched on, how this multi-region keys made the overall architecture very simple, and not only for the provider, but also made the customer's experience also very simple, where they have to just provide one key ARN. So just to kind of give you a little more detail on what multi-region keys are. Multi-region keys are KMS keys that share the same key material and are associated or linked with each other. So data that is encrypted in one of these keys can be decrypted by the associated and any other associated key. So essentially, the customer first creates the primary key in a region, and then they can replicate keys in additional regions, and all of those keys, like I mentioned, share the same key material. One of the reasons it simplifies the usage in the provider's account is, if you see, again, it's not very visible here, but if you see the ARN of these keys, it's pretty much the same, except with the difference is just the region name. So what kind of use cases these multi-region keys can really help with for the provider? Global applications, or if your application is running in an active configuration, like Zoom is, so any customer data that is coming from one region can be accessed by the application, or if the customer is accessing it from any other region. So it makes it very simplified. The other important use case that we have seen providers actually using it for is disaster recovery. So say you have customers' data in the primary region encrypted through the customer's key, and that data is backed up in a different AWS, say, backup region. In the rare event of the primary region outage, the data, which is already encrypted, sitting in the backup region, can easily be decrypted if the customer is using a multi-region key. And not just that, when the primary region, say, comes back, any new data that was accumulated or stored in the backup region can easily be used or transferred back to the primary region, and there is no need to re-encrypt the data. Now, there are some considerations for customers when using multi-region keys. If the provider is only in one region but do have plans to extend the solution in multiple regions, we do recommend that you ask the customer to start to create a multi-region key to start with, because a regular standard regional key can later not be converted into a multi-region key. So, which means, as a provider, if you decide, as soon as you go in multi-region and then you ask the customer to create a multi-region key, you have to re-encrypt all the customer's data. Another consideration for customers is we advise them to make sure that they only create these replica keys in the regions that are really needed or that are recommended by the provider. There is some small cost associated with these keys, and we don't like the keys just sitting around in regions where it's not going to be used. And finally, another important point, these keys, they do share the same key material, but the key policy that is applied on the key by the customer does not get replicated by itself. So if the customer changes the key policy for one of these keys, they have to tell them to make sure that the key policy is changed, or same key policy they have to apply on all the replica keys. So I won't go into the much detail, but this key policy, Amit, covered in the start, that this is a mechanism for the customer to have control over how that key is being accessed, and the way they control the access is using this key policy. So it becomes important, if they make any change, there is a reason they're making the change in the primary key policy. So just for consistency, they have to apply the key policy in all the other regions. So that brings me to the final topic of today. So this is a topic that came up mostly in customer conversations between providers like Zoom and their customers, and it's stemming more from two questions. Can we rotate the key? Because customer is owning the AWS account and the key is sitting in their AWS account, so they are asking these questions. Can we rotate the key? And if we do, are there any implications on the provider's application once we rotate the key? So the most common driver or why the customers are asking about this key rotation is compliance. That's pretty much like the major item. There are some points regarding other risks or other aspects because the key is sitting in customer's own KMS account. They may or may not have the level of details of how KMS actually manages this key. So there are sometimes questions about key leakage and any other thing or any other security concerns they need to be aware of. I'll come back to this a little more, but just to give you the answer to the first question, that yes, KMS does support key rotation. Customers can enable key rotation either when they create the key, or they can also enable it anytime later. Once key rotation is enabled, KMS will rotate that key once a year from the day the rotation was enabled. So coming back to just wanting to make a point here is that our guidance is, unless you're doing it for compliance reason, there is no need to rotate the key in KMS. There is no reason to think about any risks that we are aware of that from like key leakage or any other risks also. Amit mentioned in the start how the KMS works, but I just want to double click on that. The customer key never leaves the secure boundary of HSM unencrypted. So we don't have any human interface to that key. There is no API call that can access or export that key. The only time that key gets invoked is when it gets decrypted from within the secure boundary and protection of hardware security module or HSM. So that's why we don't really believe that there is any risk of key leakage or anything else similar to that even using KMS. But we do understand that customers are under compliance, auditors, or at times NIST guidelines that require them to rotate the key. So that's why key rotation is a valid feature, can be used by customers. Now coming to the last question, second question for this that customers are asking, are there any implications on the provider side? So an easy answer for all the providers sitting here is no, there is no implication. KMS makes it easy for the providers also whenever customers actually rotate the key. So just to understand what key rotation, how KMS does key rotation and why there is no implication is, when KMS rotates the key, essentially it creates a new key with key material, but it saves the old key along with it indefinitely. So whenever there is a request to encrypt data, KMS will use the new key, but when it receives a request to decrypt data that might have been encrypted using an older version, KMS will automatically use the respective version of the key to decrypt the data. So there are no implications even if keys gets rotated multiple times. So with this, we come to the end of our session today. If you like to know more about how Zoom implemented this solution, you can look at this QR code. There is a blog that explains a lot in detail. And for the providers in the room, if you have any further questions on how to implement this solution or any question regarding any of the topics that we covered today, please reach out. You can email us anytime. And finally, for the Zoom customers in the room, if you like to get this or implement this solution, you can reach out to your Zoom reps or perhaps reach out to Karthik. So we'll be around. Any questions that you have, we'll be happy to answer that right now or outside on the left side in the lobby. Thank you so much.